Okay, let's do 4.4. It says simplify the single logarithm. So we're just supposed to simplify. Well, a negative is like a -1 in front. A negative can go up as a power, and a -1 power on 1/7 turns it into a 7. So this is just log base 3 of 7. When we have to add logs with the same base, adding is the same as multiplying, so it comes from multiplying. You add powers when you multiply. I should say it that way. So log base 4 becomes of 3 times 7, or 21. This one, when you add, you multiply. So this becomes log, and this is understood base 10 because there's no base written, of these two things multiplied. So that's 6. 2 times 3 is 6. X to the 4th times x to the 5th is x to the 9th. So it's the log of that. 12. We subtract, so we're going to divide. These are both log base 10, so that we can do this. When you subtract your powers, it's from a division, so we got log of 12x to the 4th over 4x. But this reduces to 12 divided by 4 is 3, and x goes into x to the 4th. You subtract the powers, and you get x to the 3. X and x to the 4th, it turns out to be x to the 3rd. So this is just log of 3x to the 3rd. This one. So this one is a subtract, and this one's an add. So the add ones can go to multiply. But first, we're going to take care of the numbers in front and put them up as the powers, according to one of our rules. And this half will go up as a power, but y to the half is just the square root of y. So the half is out, the 3 is up there. And then these are going to be multiplied because it's plus and plus. So we got log, these are all log base 10, of x times z to the 3rd. And this is the -1, so that's a divide by square root of y. Okay. Now we're supposed to expand. So we're going to do just the opposite of what we just did on that one. So this is going to be log of a squared, but log of a squared, the 2 comes down and makes 2 log a. And this is times between these two, so plus, and the power is going to come down on the b one, so it's going to be 3 log b. And this one's in the denominator, so it's going to be subtract. And the 5th power comes down, so it's going to be 5 log c. Now, I'm just going to write it, the in-between step that I did in my head up here. So these are multiplied, so it's the log of this one plus the log of this one minus the log of this one. And the 5 comes down, the 3 comes down, and the 2 comes out in front. Because when you got a log of the log, which is a power, to a power, you multiply the powers. Multiply this power by that power. Okay, 21. So we have square root, which is just the 1/2 power. And I could actually distribute the half into this because they're multiplied. So I could call this log of x to the 3/2 and y to the -2. So then we've got a product here. So we've got the log of x to the 3 halves, but that can come down in front. And then I've got, these are multiplied, so plus log of y to the -2, but the -2 can come down. And we can have it this way. Now, there are other ways to do this one. I could look at that 1/2 and take it out right at the beginning. Let's do it that way. We could call this 1/2 log of x to the 3rd, and y to the -4th means it could be in the bottom denominator, the 4 to the +4th. Or I could have left it -4, either way. And then when I split this up, it could be 1/2 times the log of x to the 3rd. It becomes, these are divided, so it could be log of x to the 3rd, but the power could come down. And I would be subtracting, and it would be the log, subtracting because of the division. You subtract powers when you're dividing, so log of y to the 4th, but the 4th could come down. And I claim that this is the same as this if I just distribute the 1/2 times this, and the 1/2 times the -4 is -2. And there are other ways to do it. Okay? So here we got a log, natural log of two things divided, and the square root's like a 1/2 power on the denominator. So I have natural log of x minus, because it's divided, natural log of 1 minus x squared, all to the 1/2 power, but I'm going to pull the power down out in front. I can't split up these because it's addition or subtraction inside the log. It's not addition or subtraction between logs. It's inside the log, and you can't split up the log of addition and subtraction inside it. So that's it for that one. All right. I guess that's it. Okay, 27. Don't have same bases, so I make them the same base. I'm just going to use, you can do 10 to the log 4, or e to the natural log 4 for 4. So e to the ln 4 is 4. And that is to the 4x minus 7 equals 3 is e to the ln 3, and that's to the 9x minus 6. So if I distribute ln 4 to this, multiply these two quantities, and multiply these two, both sides would be e to that new power, and so the powers have to be the same. So hopefully I'm not losing you by saying I'm just going to multiply this times that. So I'm going to have x that's multiplied by a 4 ln 4 and a -7 that's times an ln 4. And that would be e to this, and the other side is going to be e2, and so I'm dropping the e. And this is going to be ln 3 times 9x is going to be x 9 times ln 3, and ln 3 times -6 is -6 ln 3. Now I could figure out this number on my calculator right now, this number, and this number, but I have to deal with messy decimals. I'm going to do something a little different. I'm going to say I'm going to subtract this from both sides. this here. So I'm going to go minus x 4ln 4 and minus x times 4ln 4. That will get all of my x's on this side, and so then I'm going to move my 6ln 3 to the other side by adding 6ln 3 to both sides. And now I'm going to use what we did in the previous section. This becomes 6 can go up as a power, 7 can go up as a power, and I'm subtracting, so I'm going to have ln of, this is the positive one, so it goes in the numerator, 3 to the 6 over 4 to the 7. That's what these two put together are. These two both have an x, so I factor it out. And it's going to be, this one's positive and this one will be the negative. So this is going to be ln 3 to the 9th power, moving the 9 up, over 4, the subtract makes it go division inside, to the 4th. So my final answer would be x equals ln of 3 to the 6th over 4 to the 7th. Divide both sides by this, over ln of 3 to the 9th over 4 to the 4th. And I can't do anything other than type that into a calculator and get an answer. So if I had gone to decimals here, I should get the same answer as I'm getting from this. I probably should show that. So I have, I'll do these here. Let's see, let's move this over here. So negative 7 ln 4, close parenthesis, plus 6 ln 3, enter. So this becomes negative 3.11238 equals, and here these are gone, those are gone. Both of these are times x, so I'm going to write x times, and it's going to be 9 ln 3, close parenthesis, minus 4 ln 4. So I got 4.34233, and I'm going to take this one, my answer from the previous one, divided by that. So I'm going to go second, enter. That's the previous one. So there's this number. That was this, so I just wrote it, brought it back. And I have to divide that because I'm going to divide this into that. So divided by my last answer, and I get x to be negative 0.71675. Now let's type it in this way. Hopefully I get that same answer. So it'd be ln of parenthesis 3 to the 6th divided by 4 to the 7th, close a parenthesis on the numerator, divided by ln 3 to the 9th, close the parenthesis, divided by 4 to the fourth. Close parenthesis. And that should give me the same answer. And it didn't. Negative 7 ln 4 plus 6 ln 3. All of that divided by 9 ln 3 minus 4 ln 4, which was this answer. And this should give me the same answer. Oh, I see. I got an extra parenthesis in here. I see what the problem is. The ln automatically starts with a parenthesis, and I added another one. And so I need to get rid of that. And now it should be. There it is. Now they match. Okay. Good. Okay. The only reason I worked this one all the way out doing it this way is just to show you how you can get it down to something that's exact for x. But I'm fine with you just doing it in the decimals that way. So let's look to 30. Now we got a problem where the bases are not the same. So let's just go to a common base. So this 20 is e to the ln 20 times e to the ln 1.07, and that's to the x, but the power will come down times. And on the other side, we have e to the ln 8, e to the ln 1.13 to the x, but the x comes down and multiplies. So this plus, because this is multiplied, we add the powers. So this plus this, ln 20 plus x ln 1.07 should equal ln 8, multiplying, so we add the powers, x ln 1.13. Now let's figure out x. So we'll subtract this from both sides. And we'll subtract ln 8 from both sides. So I'm going to have ln 20 minus ln 8 has to equal, and x is times both of them, so it's going to be x times ln 1.13 minus ln 1.07. So I have to divide both sides by this number. I could put those together somehow, but I'll just go ahead and do the calculator. So I got parenthesis ln 20, close that ln, minus ln 8, close that one, and then close this whole quantity, so the whole thing is being divided by then this whole quantity, so open parenthesis, ln 1.13, close that log, minus ln 1.07, close that, close the denominator, and I get 16.79449, whatever. That's what x should be in number 30. I'm going to do a quick check by storing that in x. Store that in x. And we're going to go 20 parenthesis 1.07 close parenthesis to the x This side is equal to 62 point blah, blah, blah. Now let's check the other side. 8 parenthesis 1.13 close parenthesis to the x, and they are equal. Carrying that many decimal places, they match up. If you rounded off in this, you're going to get approximate answers. Okay, next one, 33. Okay, if I don't like the way it looks, we try rule number 1, change it to a power equation. So to what power to take 2 to get this? I take 2 to this. This is the power, this is the base. 2 is the base, this is the power, equals 7x plus 6. Oh, this is just 8 equals 7x plus 6. This is the algebra 1 problem. Subtract 6, divide by 7, and x equals 2/7. The only thing we got to do is check and make sure this we can use this in here. See, 2/7 times 7 would be positive plus a positive. It should work, but 2/7 times 7 is 2. 2 plus 6 is 8, and yes, 2 to the third is 8. Okay, 36. Well, let's get it down to just a single log, what we had here first. So we can either put the 4 up as a power, or we can subtract 5. Divide by 4. So instead of putting the 4 up as a power, I'm dividing it out. And now I'm down to a single log. When you're down to a single log with the x in there, rule number 1. We're going to rewrite this. The base on ln is e, so we have e to the negative 3/4 is 5x. So if we divide by 5, this is the exact answer for x. The approximate answer is e to the negative 0.75, negative 3/4, divided by 5. There's the decimal answer, 0.09447. 39. Like we were doing here, get it to a single log. Well, we got a log plus a log, so we multiply. So we got log of x times x plus 3, x squared plus 3x equals 3. Single log expression, so we use rule number 1. 10's the base, to the third, base power equals x squared plus 3x. Oh, this is 1,000, so I subtract 1,000 from both sides and I get 0. I'm making it equal to 0 because it's quadratic. X squared plus 3x minus 1,000. That might factor, it may not. If you've put in the quadratic formula into your calculator, you'd be in good shape here for just saying, okay, what's A? 1. What's B? 3. What's C? Negative 1,000. And I get 2 answers. I could also type it in Desmos and tap on the x-intercepts. But again, the important thing is this is a quadratic, and so you have to make it equal to 0 to start off to solve it. Anyway, I got 2 possible answers, 30.158 and negative 33.158. I can't do logs of negatives, so the negative 33.158 doesn't work, and so the only answer for x is 30.158. And let's just do what we've done before. 30.158, 33224, store x, and let's just check. It should be, there we go, log x, close parenthesis, plus log x plus 3, close parenthesis, should equal 3. Oh, it didn't. Oh, I didn't put plus in there. Get back over here. Plus. I hit minus. There, it's equal to 3. Good. See why it's good to check? All right. Here we got minus to make it down to a single log, so we can use rule number 1. Minus means divide. So we got log of x plus 5 over x plus 2. When it's minus and subtract equals 2. Rule number 1 says 10's the base. This is the power. Don't like having the x plus 2 in the denominator, so I'm multiplying both sides by x plus 2. So 100 times x, 100 times 2 equals x plus 5. Subtract 1x from 100 x's, 99 x's. Subtract 200 from both sides, and I get equals negative 195. Divide by 99, and x will equal negative 195 divided by 99. And can I use that number? So let's go back to the original problem. It's negative, but since we're adding 5, that would make a positive number here, so that's okay. And we're adding 2, so that would be positive. So looks like we can use the negative 1.9696, whatever. Let's find out. Store x, make sure that we've got the right answer. Log x plus 5, close parenthesis, minus log x plus 2, close parenthesis. It's supposed to come out to be 2, and it does. All right, just a couple more. In 4.6, let's see, I do 34. Let's do 34 first. The light, as it goes into water, the water, if it's dirty, the light intensity will go off pretty fast. If it's pretty clean water, it will go off, get darker less quickly. But in both cases, they're exponential decay equations. So it says it decreases by 15% for every 3 meters. So to write this, it's going to be the intensity at the surface, I0, then starting intensity, will decrease e to the loses 15%, so it keeps 85%, so 0.85 to the okay, there's actually it's a good question here whether we're doing continuously decreasing or decreasing every 3 meters. So it could be written, I'm going to write it both ways. It could be 1 minus 0.15, which is the 0.85, to the distance down, but it only does it for every 3 meters. So if I say d, I'd have to divide it by 3 so that at 3 it does 1 unit of 3 meters, and then if I put 6, it would be 2 times it would go to this. Over here, we'd also do times d over 3. This will decrease it a little more than the other one. So that's going to be the intensity at some depth in meters. Same here, intensity at some depth. This is a decreasing continuously model. This is decreasing every 15% for every 3. The book probably uses this one. It might be reasonable to use that one. At what depth would it be 1%? 1% of what it started. So this would have to be 0.01 or 1%. And this would be 0.85 to the d over 3. Or if I was doing this model, this would have to be 1%. To the 0.85 d divided by 3. To solve it, when we got a power like this, we're going to use rule number 1 to take it back to logs because we're trying to solve for a power. So going back to a log, the base is e, ln, log base e. This is the power, or this is the power, and we're solving for it of 0.01 equals the power, 0.85 d over 3, and I'm going to put just it under there. So this divided by that is one possible answer, or in this model, it's going to be the base is 0.85, so log 0.85. This is what we're trying to get. 0.01 equals d divided by 3, and so we'd multiply both sides by 3. Let's see how these two answers compare. They should be somewhat similar, but not exactly the same, because we're modeling it two different ways. ln 0.01 divided by parenthesis 0.85 divided by 3. Negative 16 meters deep. Why is it negative? D is not supposed to be negative, I don't think, here, because that means above the surface. ln base e equals this divided by this. Okay, well, let's see what the other one comes out to be. To do log base 0.85, it's going to be log of this divided by log of 0.85. So log 0.01 divided by log 0.85. I'm going to get an answer. Then I'm going to take times 3 to get the 3 over here. It says at 85 meters deep. Oh, I know why. I know why. I wrote this wrong. If it's decreasing by 15%, it's negative 0.015. So negative 0.15 should be up there. Negative 0.15, because in this model you do the APR, and it's decreasing by that. In other words, how much it's increasing or decreasing, not the growth factor, but how much it's increasing by. So let's go back and do this one. It should have been ln of 0.01 divided by, this should be negative 0.15. 0.15. So this one says that we have that 92 meters deep. The other model says 85 meters deep. So we get somewhat similar answers. This model says it takes longer to get to that than this model. But you got an idea of, I would accept either way on that one. And that's kind of like on our test, the first problem. There's a couple ways to interpret that. Okay, this one is not just a straight one, so this is not the y-intercept because it's 1 minus something in here. What's the length of a newborn halibut? That would be at times 0. So we put 0 in here. And 0 times this number is 0. E to the 0 is 1. So 1 times this. So we're going to take 1 minus this times 200. Let's actually just type this equation in here because that might be helpful. 200 parenthesis 1 minus 0.957 e to the negative 0.18x. Okay. Type it in there, and so then I can go to my table and just get rid of all these. And they want a newborn, 0. And it's 8.6 centimeters, I believe it was. Length in centimeters. Just put 0 in here and you get that in and work it out. Use the formula to estimate the length of a 6-year-old halibut. So 6. Let's see. Why am I getting 2? Oh, I don't want this thing. $135. 135 centimeters. At what age will you expect it to be 120? So now we have to get this equal to 120. So we got 120. It should be somewhere between 0 and 6, probably about 5, since 120 is almost 135. But we're going to have, just kind of thinking ahead, 20, 1 minus 0.957 e to the negative 0.18 t. Now to solve this, we want to get it down to just one thing to a power, a single exponent, so that we can rewrite it as a log. Because we're solving for a power, we want to use logs. We could distribute the 200, but I'm just going to divide it out. And 120 divided by 200 is 0.6 equals 1 minus 0.5957 e to the negative 0.18 t. So I'll subtract 1 from both sides. So 1 minus 1 plus 0.6 is minus 0.4 equals minus 0.957 e to the negative 0.18 t. Going to divide this number out. So I'm down to just e to the negative 0.18 t equals a number, negative 0.4 divided by negative 0.957. Oh, yeah, I did, no. 2, go to my problem and change that to a negative, not a subtract. So I've got this becomes 0.41797, blah, blah, blah. And so writing this exponential as a log, the base is e, so ln log base e of what I'm trying to get, 0.4179 blah 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 equals negative 0.18 t, so I got to divide by negative 0.18. So I need to take ln of this answer divided by negative 0.18. So I'm going to type in. Notice that I was not showing you things here. Writing this as a log, the base is LE, so it's ln of what I'm trying to get, solves for the power. So ln of my answer divided by negative 0.18 says t, the number of years old, to be 120 centimeters long, is approximately 4.8 years. It'll be 120. 6 years, that'll be 135. Okay.